Hello students, in this video I'll be going over two selected angle proofs. They're for Common Core Geometry, so they might be proofs that you would see in your Common Core Geometry class. Let's take a look. So we've labeled that since these two angles are congruent, we've given them arcs in our diagram. The next piece of information tells us that E is the midpoint of BD. Again, midpoint is going to be kind of similar to bisect because if E is the midpoint of BD, that means it cuts BD in half. It makes two congruent portions of line BD. So I'll mark that now. So you can see the markings where I fixed the diagram. It says that BE is now congruent to DE because E is the midpoint of BD. Last but not least is telling us that EAC is a straight line. This might not seem like very important information, but it's a clue as to what we have to do next. And it also tells us C to A to E is a straight line. It's not like from C to A goes straight down, but then from A to E veers off this way, something like that. It's a straight line. So the next thing that it wants us to do is to prove that triangle BCA is congruent to triangle DCA. So let's mark up the diagram with that particular triangle. So I've color-coded it here for you. I'm trying to prove that the purple triangle, which is BCA, is congruent to the orange triangle, which is DCA. So we see that we already have an angle here that's going to support that. That's angle BCA and angle DCA. But in order to prove triangles that are congruent, we need a couple more pieces of information. We could use angle, side, angle. We could use side, angle, side. There's a big list of different triangle congruence proofs, and I'll list them here. So here they are: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. One of them we can eliminate right away. Nothing in this problem says that there are right angles. Nothing here says perpendicular lines. So hyp leg is probably not going to be the one that we're looking for. Wow, that's quite a line. We do, however, know that there are two angles that are congruent. So this piece of information is definitely going to be handy to us. I don't think that we're going to use a side, side, side method because we already have an angle that's sort of given to us. So while looking at the problem, we should be looking for either side, angle, side, which is two sides with an angle between them, angle, side, angle, which is two angles with a side between them, or angle, angle, side, which is two consecutive angles and a non-included side. So let's take a look at the diagram and see what we can do with it. One piece of information that you should remember from your class is the reflexive property. And you should remember that the reflexive property tells you that a structure, like a side or an angle, is congruent to itself. That's useful when that structure is included in two different triangles. For example, line CA is included in triangle BCA, which is here, and also triangle DCA, which is here. So this side is congruent to itself. I'll mark the diagram with that information. So I wrote down this quick note, reflexive property, which states that a structure is congruent to itself. And in this case, we know that side CA is congruent to side CA. So we have a side, and we have an angle. Now, the easiest thing to do, which we have to figure out, is whether to find BC is congruent to CD, or which would give us side, angle, side. Or we could try to figure out whether CAB is congruent to angle CAD. That would give us angle, side, angle. Alternatively, we could find this angle, which is CBA, and this angle, which is CDA. That would give us angle, which is CBA, angle, which is BCA, side, which is CA, is congruent to angle, ADC, angle, DCA, side, CA. It looks like we don't have a lot of information about this angle or this angle, but we do have some information about this angle and this angle, which is angle BAC and angle DAC. We know that those two angles are in a straight line. That's why they give us this EAC here. So if this angle is in a straight line with this angle down here, BAE, and this angle is in a straight line with this angle, which is EAD, that means they're supplementary. And we know the congruent supplements rule, which is if these two angles are congruent and these two angles are supplementary to those congruent angles, they must also be congruent. So let's try to put this all together. I'm going to start writing the proof here, and we'll take it step by step. All right, the first part of the proof is really a cakewalk because it gives us all this information. all of these four different statements are given to us. So EC bisects BCD, ABE is congruent to ADE, E is the midpoint of BD, and EAC, they're all givens. You could condense these into all one statement. For example, statement 1, this and this and this and this, all given. The reason I like to separate it is because later on we can refer back to each individual step. So for the fifth step, the first thing that we did in this diagram is identify these two arcs. In other words, BCE is congruent to DCE. And we know that they're congruent because this line, CE, is bisecting BCD. So let's write that in. So we've written down that BCE, which is this red angle, is congruent to DCE, this red angle, because of the definition of an angle bisector. Next, we're going to prove that CA is congruent to CA. And we know that because of reflexive property. So remember why this is important. We're eventually trying to prove that these two triangles are congruent to each other. So we have an angle and a side now. Now all we need is either another angle or another side. And we can prove that these two triangles are congruent. The next step is to prove these markings down here. We've proved that BCE and DCE are congruent. Now we have to prove that BE and DE are congruent because of the midpoint. So we'll do that next. All right, we've settled out that BE and DE are congruent because of the definition of midpoint. Now we're going to prove that ABE and ADE are congruent. Oh wait, we don't have to because it's already proven. Nice. Now remember the plan that we made. We're trying to prove that this angle, which is CAB, and this angle, which is CAD, are congruent. We need, in order for that to happen, to know that these two angles are congruent, which is BAE and DAE. In order to prove that these two angles are congruent, we need these two triangles to be congruent. So we could use Cpctc, which is an abbreviation for corresponding parts of congruent triangles are congruent. In order to do that, we're going to need to prove that these two triangles are congruent. And we're going to use the two angles that we have and these two sides that we have, as well as this side. So you should be able to see that we're very close to proving that these two triangles are congruent. The only thing we need now is to use the fact that this triangle here is isosceles. Isosceles, you say? Why is that? Well, I know that this base angle and this base angle are both congruent. So triangle BAD is isosceles, which means that this side, BA, is congruent to this side, DA. So the next thing I'm going to write is that this triangle is isosceles because of those base angles, and then I'll further state that BA and DA are congruent because of the definition of isosceles triangles. All right, so BA is congruent to DA because of the definition of an isosceles triangle. So we have these two smaller triangles, triangle BAE and triangle DAE, and they have the condition that their side and angle and side are congruent to side, angle, side. That means that these two smaller triangles happen to be congruent. So that's the next thing that we're going to state. So there's our statement, keeping in mind that we're observing directionality. We go from B to A to E, and we also go from D to A to E, which means that, like, for example, D corresponds to B, A corresponds to A, and E corresponds to E. So that tells us that these two triangles are congruent to each other. Now that we know that they're congruent, we can say that this angle, BAE, and this angle, DAE, are congruent to each other because of corresponding parts of congruent triangles being congruent. Let's write that in. So you see the markings on the diagram, and you also see the statement here. I've given as my reason Cpctc, as I stated in class, and I state to all my students, you should write this out as corresponding parts of congruent triangles are congruent. I'm doing this because I'm running out of space on my whiteboard. Okay, next, we know that these two angles, BAE and DAE, are congruent. We also need to prove that angle CAB and angle CAD are congruent. We do that by saying that since this angle and this angle are a linear pair, this angle and this angle are a linear pair, then these two angles are supplementary to these two angles. And if they're supplementary to congruent angles, they must be congruent. I'll write that in. So before I write this into the proof, I wanted to show you that if two angles are supplementary to congruent angles, then the two angles are congruent. That's otherwise known as the congruent supplements theorem. So this is a theorem that you may want to jot down. You might want to pause the video and jot this down. It's called the congruent supplements theorem. Now I'm going to apply it in this situation. So now we've reached 4 arcs on these congruent angles. We see that this angle is congruent to this angle because of the so-called congruent supplements theorem. Last but not least, we have angle, side, and angle. Angle, side, and angle. You know what that means? If this angle and this side and this angle are congruent to this angle, this side, and this angle, then the 2 triangles must be congruent based on angle, side, angle. All right, we've successfully used angle, side, angle to prove that these 2 triangles are congruent. The good news is that this proof is over. 13 steps, not too bad. The even better news is now you can go back and rewatch the video to make sure that you understand every piece of it and try to set it up yourself. All right, that's all the time I have for. I hope this was helpful to you. Good luck studying.